the sentence here, if today is Monday and not a holiday, then Randy will have the evening class. So the major rule of the rule base is if then rule. And why this is a so-called expert system? Expert, that means this system will mimic the opinion of the human expert. And the knowledge of the human expert will be coded into the artificial intelligence system. So the system will be able to solve the problem related to some field or some domain. And the rule base contains a set of conditions or a set of if-then rules. So in the if part, we will have the facts, and in the then part, we will have the action. It's like if today is Tuesday, then I will not have the class. So the fact is if today is Tuesday, and the assertion or the action is I don't have the class. And the rule-based expert system is created by using a set of facts, or also known as the assertions, plus a set of if-then rules. So now I will discuss with you guys about how the mechanism of this system works. But just keep in mind that actually this method is not so difficult. It's about if and then. So if P, then Q. Okay, this is the very basic rule. And later on it will have some other more complicated discussion. But don't worry, the main idea is still very simple. Okay, so in the if P then Q, P will be called as a set of facts or assertions. And the facts and the assertion will be stored in the knowledge base. There's one knowledge base. And the Q is the actions. And the if then is a rule. And in this system, they also have the termination criterion. That means once the if then rules start to firing, it will create a loop. And sometimes the loops have to stop to fire the new loops. Right here is still very ambiguous, but wait for a while. When I discuss further, then we will understand deeper. So the facts, so the rule is the if-then rules, and the facts contain the data and the condition. The data is also known as the object, and the condition is the value or the attributes of the object. I will give the example. For example, if the temperature is less than 0 degree, so the temperature is the object, and the less than 0 degree is the value or the attribute of the object. And these two things combined will create the facts. Here's another example. We have in the object we have the season, the temperature, the wind blowing, road weather forecast, and the condition we have. The condition we have for temperature is less than or more than 0 degree. For wind blowing we have strongly or gently. For the road we have slippery or not slippery. Weather cold, warm, hot. And forecast no or snow or no snow. So the rule-based system will work like it will combine the data and the condition and create the facts. And then it will combine a lot of facts or or even the single fact to create the conclusion. So in this example, the rules use 3 facts. If temperature is less than 0, and if windy blowing is strongly, or if the road is slippery, then the conclusion is cold. Why I highlight the term cold? Even because in this example, the cold is already here, but by the premise, by the rules, then the cold will be combined with this condition. Or if the code is not in the database in the beginning, then if the rule-based system create the code in the assertion, then this data will be the new data and will be added to the database. And We have four major types of rules. The first one is a lot of premise, or we can also call antecedents. Sorry.
Antecedent.
Yeah, antecedents. And a lot of premise will be combined with and. The second one is a lot of premise will be a lot of condition will be combined with or, and the next is and or. Or we have the condition with a lot of consequences. The purpose of separating into and or, this is because we also have the algorithm. We have the algorithm for each type. For and we have one type. For or we have another type. And I will discuss later. But keep in mind, otherwise you forget. And this one is the basic structure of rule-based export system.
No, I take picture for you, not for because I would like to bring some memories for you. We study, I think when you finish your PhD degree, I should prepare some gift for you. I think I will collect all of your, because you attend several courses from me. I would like to prepare an album for you. But I must say that I see your progress in the past times. Really, really good. Very nice. Go ahead.
So for the basic structure, we have the knowledge engineer. The knowledge engineer right here. The knowledge engineer indicates a combination of the expert in the artificial intelligence field and the expert in another field, like in the medical field. The expert from the medical field, they will provide the knowledge about medicine or about hospital or about the treatment. And they will pass on this knowledge to the engineer in AI field. And the engineer in AI field, he will try to code all of this knowledge into the system. That means initially the knowledge is in the brain of the medical expert. But then the AI expert, he will try to encode all of this knowledge into the system. So the system can think or can have the knowledge like the medical expert. And the knowledge base will contain the if-then rules. And the database will contain the facts or the assertions that we have seen in the previous slides. For the inference engine, right here they contain some algorithm and some logic. So the engine will compare the facts and the rules together. If the fact match with the rules, then the new fact or the new conclusion will be generated. So the new conclusion will be added into the database, and the adding process is a so-called knowledge acquisition subsystem. That means from the fact given in the beginning, it will learn another fact, and it will add the learning fact into the database. There are two major types of rule-based expert system. We have forward chaining system and backward chaining system. Here I give the example, but first I will describe a little bit. We can see the facts here is 5 facts. We have 5 facts, A, B, C, and D. And we have 5 rules. We have the database and we have knowledge base. So in the knowledge base, we have 5 rules. And in the database, we have 5 facts. 5 facts and 5 rules. So the forward chaining system, you try to work from the fact toward the final rule, or we can call it the final conclusion. But the backward chaining system, you try to work from the final goal backward to the initial facts Okay, now we will discuss in detail the forward chaining system. This is the diagram of how the forward chaining system works.
No, it's funny. Just say, and I will make the picture for you. For your memory, it's not just as a thing.
Yes, sir.
Don't worry about it.
This is the diagram of how forward chaining system work. This diagram I borrow from the chapter, but I also add some explanation right here. We can see here we have the user, and here we have the working memory. Initially, the system can contain like 100 facts, 200 facts, and 100 rules. But when the user input the fact into the working memory, they can use less than 200 facts. For example, they can use 10 facts. So the rule base right here, the system right here, will identify the applicable rules, which is relevant to the fact given into the working memory. So from the 100 rules, the rule base will not use the total 100. It will based on the 10 given facts and decide what will be the possible rules to be used in the specific case. So for example, the rule base right here will determine the possible rules like 10 rules. So for example, we have 10 facts and 10 rules. And after that, the system once again will find which fact and which rule is relevantly matched. So if the matching is happened, then the rule will be applied for the fact. Right here is still ambiguous because it's diagram, but later I will have the demonstration. Yeah. So if the rule is found, that means the new fact will be created, and the new fact will be added into the working memory, and the rule and the rules that is already used will be removed. I give the example that we have 10 rules right here. So after the new fact is generated, so the rules now we have only nine rules. So in the and then the system will exit and start the new loop. So in the new loop, the rules is only 9 rules, and the fact we have the new fact. So the system will work with the remainings of the applicable rules and the new set of the facts. This is the example. It was the same example that I saw in the previous slide. We have 5 facts given in the database, A, B, C, D, E, and the 5 rules. And the final goal is to read the Z. The Z is the final goal. So for the forward chaining system, it will work from the fact until it meets the final goals. So for the first rule, it has if A and C then B. Because A and C is already in the database and B is already in the database also. So this one is a reconfirm of the facts. So the system will quit right here. So it will start the new loop. And in the new loop, the remaining rules now only have 4 rules, 2, 3, 4, and 5. In the beginning, it has 5 rules. But after it finishes the first loop, then now it only has 4 rules. So it will only work with the 4 rules. So in the second rules, it finds, okay, C is in the database, E is in the database. So the root will be fired, and C and E will create F. So F is a new assertion, and later on F will be added into the database. That means the database now will have the 6 facts other than the 5 facts. Originally it has 5, but now it has 6, and the rules will be reduced. And then the system will exit again, and it will start fire again with the rule number 3. And right now we only have 3, 4, 5, because the rule 1 and rule 2 are used already. So the system will remember, because it already removed it from the working memory. So the root number 3 will be fired, and we have C, D, E in the database already. So this 3 facts will create a new assertion. This is X. So later X will be also added into the database. Okay. It will be only 2 here. Oh, sorry. Yeah. So now the database have A, B, C, D, E, and F. And after that, since the database have X, and the condition to have the Y is A, B, and X, so the X will be added and the Y will be created. And after the Y is created, now it can satisfy the condition right here. Because the condition right here needs Y to create the Z. But in the beginning, Y is not in the database. So this is why it has to go top down. And so finally, after the X is created, then the rule number 5 will be fired and Z will be created. And then Z will be, because Z is a final goal, so right here the system will stop working. Because it reached the goal already. That means I grab the goal, okay, now I quit. This is the forward chaining system. So what is the difference of forward chaining system and backward chaining system? I will use the same example, but it will be applied on the backward chaining system. Still we have 5 facts in the beginning and 5 rules in the beginning. But for the backward system, it will go from the goal, the final goal, backward to the initial facts. So it will assume, it will make the assumption that now, okay, now we have Z. We already have Z. So the Z will be here. And for Z to be created, it needs D and Y. D is already in the database, but Y is absent. So because Y is absent, so Y will be the next sub-goal right here. And how can we achieve Y? We should have A, B, and X to have Y. A, B is already in the database, but X is absent. So X will be another sub-goal. And how to have X? It needs C, D, and E to have X. And C, D, E is already in the database. So the system will realize that actually to reach the goal Z, it don't have to go from the rule number 1 and number 2 toward rule number 5. It can start from the rule number 3 and go down until the rule number 5. So by using the backward chaining system in this case, we can skip the root number 1 and number 5. The system will not use the root number 1 and number 5, number 1 and number 2. So the time will be shortened than the forward chaining system in this case. So to sum up, the forward chaining system will go from the data toward the final goal, and the backward go from the goal and go backward to the initial facts. So by using the backward chaining system in this case, the system only use 3 rules, 3, 4, and 5 to create the goal Z, other than going from the root number 1, 2, 3, 4, 5 like the forward chaining system. This is the same but with color. Yeah, I should open this one. The more colorful, then it's easier to understand.
Yeah.
But I forget. So I present already in the previous slide, but this one is like, how can I say? This one add more color.
Yeah. Okay.
Okay. So I go to the next.
Next, yeah.
Very nice.
And this one is a general diagram of the backward chaining system. I already explained in the example, so it might be easier for you guys to understand this diagram. Actually, I intend to explain the diagram in the beginning, but it will be more complicated. So this is why I introduce the example first,
Example.
and this one we will go later. So the mechanism is the same to the example of the backward chaining system. Oh, Right here we can see the conflict resolution strategy. These terms feel like, oh, so complicated, but actually it's very simple. The conflict resolution strategy indicates the order of rules to be fired.
Yeah.
Because we have a lot of rules. So how can we know which rules will be used first? So the conflict resolution strategy, you have to define which rules among a lot of rules will be fired first, will be triggered first. And they have five major methods of using how can I say, of arranging the order of the rules to be fired. The first one is first applicable. First applicable is like first in, first out. The one on the top will be used first, and it will go downward. And then the random one is like, okay, fly phone, this is the random one. And the most specific, that means the rules that has the most conditions will be used first, because for the most specific, it focuses on the detail of the condition. That means the more detailed the condition is, then the higher probability to be fired first will be higher. And the fourth one is the least recently used. The least recently used is like, right here we can see the rule number 1 has been used long ago, while rule number 2 and number 3 is just used recently. So this one is the least used. So the least used will be fired first. But the best one is not yet to come. This is the best one. The best one is the so-called best rule. For the best rule, every single rule will have the weight value. So the rules that has a higher weight value, that means it has a higher credibility, will be fired first. For example, if rule number 1, the weight value is 30%, and rule number 2 have 70% in the weight value, then the rule number 2 will be fired first. This is just my comparison about forward and backward chaining system. I have said that for the forward chaining system, it go from the data to the goal, and for the backward go from the goal to the data. But when we should use it, for the forward chaining system, we will use when there are so many hypotheses. And the backward one will be used when the facts are very large. How can I say? If the fact and the condition are very large, that means we have a lot of conditions. We don't want to go from the top and down to reach the goal. So in this case, we will go from the goal and go backward to see what facts is matched or is relevant with the condition. So this is when we should use this tool. Okay, I forgot. Yeah, and it's like for the forward chaining system, it may answer the question, what do these symptoms suggest? The symptoms mean the condition, the evidence. And the backward mean, how can I say, the backward chaining system may answer the patient suffer from chronic insomnia. That means the hypothesis is that, okay, the patient is now suffering this disease. So will this disease will bring the insomnia to the patient?
Okay.
And I give another example for forward chaining system and backward chaining system. This one is my example. I didn't borrow the one from the book. The one from the book is way too long. So initially we have 7 facts. 7 facts and 4 rules. The first fact combined with the first rule will create the mammals. That means the animal, if the animal has hair, then it will be the mammal. And the second rule will combine the fact 2, 3, and 4 together to create the carnivore. Carnivore, that means the meat eater. The animal that eat meat, then we call it carnivore. And the fact eat meat combined with the rule number 3 will also create the carnivore. So right here we can see the OR relation. That means this is not AND relation, this is OR. That means has lower and south tip and forward pointing eyes or it meat will be the carnivore. And the fourth rule is if the animal has spots, the dogs, the spot, and the speed is very fast, and this is a mammal, and this is a cannibal, then the final one will be the cheetah. So right here, this one is a forward chaining system. It used on the given facts and on the rules to reach the final ones. But for the backward chaining system, it will say, okay, I will go from cheetah. I will not go from here. I will go from the result and backward. The cheetah is a final one, so it needs root number 4, and it needs the fact has spot very fast, mammals and cannibal to be created. But the has spot and very fast is already in the database, because in the original database we have 7 facts, and these 2 are already in the database. However, mammal and cannibal is not in the original database. So what should we do? So the system will treat the mammal and the cannibal as a subgroup. And for the mammal to be created, it needs root number 1 and fact number 1 to be created. For the subgroup cannibal, it needs roots number 2 and the facts 2, 3, 4 to be created. But right here, since the cannibal is already achieved, it will not be necessary to go through the root number 3 and the fact it meet. So in this case, how can I say? So in this case, the backward chaining system can skip the comparison of the fact it meets and root number 3. So the time can be shorter. I did it here. So out of 7 facts, it only used 6 facts, and out of 4 rules, it only used 3 rules. This one is nice. I find this one is really nice. How can I say? For the working memory, as I told you in the beginning, that the rules will be reduced and the facts will be added. How the rules will be reduced and how the facts will be added? It will be, how can I say? The adding and the removing will be operated by the read. I don't know how to read there or by this algorithm. And okay, so this algorithm will be in charge of adding the new facts and remove the used facts and the used rules. So I give the example to make it easier for us to understand. One more time, the example is not from the textbook. So actually, if there's any part that you don't understand, then just stop it, and I will go back. So for example, maybe I will sit like this. For example, we have the finance management system, the very simple one. And the duty of the mission of that system is to tell whether the account is sufficient enough to pay for the bill per month. So here we have the example. If the mortgage is due and if the account has enough money to pay for the mortgage, then it's a conclusion. Pay the mortgage and reduce the balance by the amount of the mortgage. So this is the assumption that we make. But how the working memory of the system will understand? It will understand like this. The data will be input like this. That means it has the bill, and on the bill it has the name of the mortgage, and it also has the status, whether it's due or not yet due or overdue or kind of, and the amount of the bill. And here it also has the account. Account is like your account or my account. our bank
Which
account.
account?
Yeah. And the name checking. And the most important one is the balance. So in this case, the balance is 500 and the amount is 500. That means it is sufficient to pay for the bills. So the system will work like this one. So we code in if bill, how can I say? If bill is due and the amount is 500 and the account has the balance of 500, then it will assert that pay the item mortgage and remove remove this fact. Actually, these two things are removed. These two facts are removed, and these two new facts are added. Any
Very clear.
Okay, so this is the adding and the remove. These two facts will be removed, and these two facts are exactly this. These two and the two new facts is added into the working memory. So another example, I would like to give example because it makes it easier to understand than the diagram. So if the working memory has all of this data, it's like the bill is 100 and the account is 400. So what we expect is that the system will be able to produce that the remaining balance is 300 and the bill is already paid off. So this is how the system works. Here it will say that if the balance is greater or equal to the amount of the bill, then first the bill will be paid. But the second one, the bill will be removed because the bill is paid off already, so the bill should be removed from the notification board. And next one is the account will be reduced by the amount of the bill. So the new assertion is the remaining of the account balance, 300. This is how this algorithm will work and to solve the removal and the adding of the facts. Actually, I put here thank you, but here not yet finished. Because the main paper, the main idea is finished already. But for, how can I say, for the if-then rules, we often use the words. But for the words, it's very ambiguous, so we have to give the value, the number value, to the word. So, how can I say, the Bayesian algorithm and certain factors, you have to give the value to